Hi, my name is Grace Saad, and this is my Lab01. We did a charge tape experiment. So first we're going to take a look at how to make a charged U-tape. And in this experiment, we stuck a piece of tape to a surface, and then we stuck a second piece of tape on top of that surface, and we ripped that piece of tape off. My theory in this was that the tape will become positively charged as electrons are ripped from it off by the base tape. Here in this video, you can see the tape interacting with my hand. This interaction really represents how neutral and charged objects attract each other, the tape being charged and my hand being neutral. So next we took a look at some U-tape interactions. And what we did for this was we made two separate U-tapes and we observed how they interacted with each other in addition to how they interacted with neutral objects. My theory here was that the tapes would repel each other and be attracted to the neutral objects. So here on the left, you can see the two U-tapes repelling each other as I try to move them closer. This makes sense because they are both charged of the same charge. So they would repel each other. And then here on the right, you can see them interacting with the notebook as they are attracted to the notebook since the notebook is a neutral charge. And here are some diagrams kind of describing the different interactions up on the top left. If the tape was positively charged, it would attract a neutrally charged pen, attract the electrons in that pen, and possibly have some electrons from the pen transfer to the tape. If the tape was negatively charged, the tape would also be attracted to the pen. It would be attracted to the protons in the pen, and potentially some of the electrons in the tape would transfer to the pen. If the tape was neutral, there would be no attraction between the tape and the pen. Electrons and protons would just be evenly dispersed. So here in this video, you can see the tape interact with a ruler, which was negatively charged since I rubbed it in my hair, messed up my hair, but rubbed it in my hair, it acquired electrons, so the ruler is negatively charged. And what this tells us is that since the U-tape was attracted to the ruler, the tape must be positively charged. So let's take a look at some of the forces acting on the tape when we push them, have a little floating tape moment. So in this picture, you can see the U-tapes repelling each other and kind of, pushing the other piece of tape up. And I made a free body diagram here on the right that just shows the electric force pushing up and the gravitational force pushing down. And since the tape is stationary, the F net is 0. So let's go through some of the calculations that we did for this lab. These were just my calculations for the different gravitational forces. The electric and the gravitational force are equal and opposite. And then using the equation for the electric force, I found the charge of the tape, and I found that to be 2.9 times 10 to the negative 9 coulombs. And here on the right, you can see my simulation, the green and blue dots being the two different pieces of tape, and the orange vector is the electric force, and the yellow vector is the gravitational force. I also then went on to calculate the total number of atoms and the amount of deficient electrons, which then I divided those by each other to find the deficient electron ratio. And I found that to be about 280 electrons per atom. This ratio does seem unusually high, and I would think that that is most likely due to human error. It also relates to some of the assumptions that we've made during this lab, and those include treating both pieces of tape as a point charge and stating that claiming that both pieces of tape have an equal charge and ignoring air resistance. All of these assumptions may have resulted in a high ratio, but also I want to mention human error because it was very hard for me to measure the distance between the two pieces of tape when I was holding one up. So that was a little bit difficult and probably caused some error within my calculations. But these assumptions are important to note because obviously they're not entirely realistic of the situation. However, it is most likely that this high ratio resulted from human error.